Hello and welcome back to Dr. Logic Awkwardly Does Logic. In this video, we're going to talk about modal reduction principles. Now, we've already seen one in the previous video, the principle that says that you can always reduce not, possibly not to necessarily. And then with some double negations and other things, you can also get from not necessarily not to possibly. That's the only modal reduction principle that the systems we've looked at validates. In fact, it's validated by system K, so it's going to be validated by all of the systems that we consider. But there's a lot more out there than just that, and we might want to consider, what are these principles? What happens if we add them to systems that we already have? So I'm going to pull up the whiteboard so that we've got a place where we can kind of take some notes about the various principles that we might want to look at. So the most obvious ones are going to be ones where we essentially collapse iterated modalities. So a principle that says necessarily P is just the same thing as necessarily P. So adding extra necessities doesn't change things. We might also want to have a similar sort of principle, or at least ask under what cases would we want to have the principle that possibility is equivalent to possibly possible. But then there's also the question of mixed modalities. So, what would happen if we had, say, necessarily possibly P? Is this, what about that is equivalent to possibly P? Or if possibly necessary P, what if this is equivalent to this? But there's also two possibilities here. I mean, it could be that we want to reduce necessarily possibly P to necessarily P, and maybe we want to reduce possibly necessary P to possibly P. So these are 6 modal reduction principles that are not valid in any of the systems that we have looked at so far, but might be interesting ones to explore. Now, note that these single reductions, so single direction implications, not equivalences, are all valid. These ones are all valid in T. We have that necessarily possibly P implies possibly P. We also have that necessary P implies possibly necessary P. We have that possibly P implies possibly P. And we have that necessary P implies necessary P. So let me just put some notes. This one and this one all follow from substitution instances of our main T axiom. Then this one and this one follow from our theorem T1, which is just derivable from T through contraposition, substitution, double negation, things like that. But if you look at these are all half of one of these modal reduction principles. So number 1 is half of this one. So number 1 is half of that. Number 2 is half of this one. It's the other direction. And then 3 and 4 are both half of these reduction principles. So this means that in system T, we already have parts of these modal reduction principles. In order to get them, in order to have their equivalence, one way is to just add the other half. So add the direction of the implication that isn't already present in system T. Now, you'll notice that nothing happened with these over here. And I'm going to bracket them for a bit. We will come back and talk about these principles once we've developed some other systems. So we will just kind of say, ignore these for now. We're going to concentrate on these 4, in part because we already have half of them in system T. So the next question that we are going to consider is, what happens if we add the converses of 1 to 4 to system T. So all of these, just flipping them around. So necessarily P, or sorry, possibly P implying possibly necessary P, or necessarily possibly P implying necessarily P, and so on and so forth. Wait a minute. Did I get this wrong? No. This one really is one direction of that. And so we want to know what happens if you take the other direction. And similarly here and here. So this is just a motivational video. Why are we interested in which modal reduction principles? We're going to start with these 4 because we already have half of them in system T, and it will be an interesting question to see what happens if we add the other half. That will be the topic of the next video. We will look at, first of all, some of these principles are interderivable with each other. So maybe we don't need to add all of them. Some of them might imply some of each other. So again, maybe we don't need to add all of them. All of this will be the subject of the next video when we start building stronger systems than T that have greater expressive power, more modal reduction principles, and you can do cool things with them. So take care until then. See you later. Cheers.